Here we have section 8.1, the geometric mean. So main ideas, find the geometric mean between two numbers, and solve problems involving relations between parts of a right triangle and the altitude to its hypotenuse. So when you're talking about the geometric mean between two numbers, that's the positive square root of the product. So down here, that actually should be an equal sign. X is equal to the square root of a times b. So it's also a over x equals x over b. So if you do the cross products, you get x squared equals ab. So then when you solve, the square root moves over. So our first example here, find the geometric mean between these two numbers. So the geometric mean is the square root of the product. So the square root of 36, which is 6. So down here, square root of 6 times 15, which is the square root of 90, which is, according to the calculator, about 9.5. Okay. So, some things that are based off the geometric mean. So if you have a right triangle, in this case XYZ, and you draw an altitude from the right angle to the hypotenuse, it actually breaks this triangle into three similar triangles. So XYZ is similar to XWY, which is similar to YWZ. And so down here, that altitude that you drew is the geometric mean between the two segments it divides the hypotenuse into. So it's equal to the product of XW times WZ. Which brings us to example 2. So here we have triangle PQR. RS is 3 and QS is 14. Find PS. So PS is the altitude. So PS is equal to the square root of the product of the segments. So 3 times 14, I believe, is 42. 42. So the square root of 42 is 6.5-ish. So we use the squiggle equal for approximately. So for this one, you're going to calculate the height of the train. So if you look here, it tells you, it gives you the length of the altitude. Tells you that distance, you're trying to find that height there. So the rules are still the same. The altitude is equal to the square root of the product. So you'd have that equation. So to solve this, you have to square both sides to get rid of the square root. So 8.75 squared, 7656 equals 5.5 times x. So now you divide both sides by 5.5. Gives you about, we'll call it 14. But that's not the answer. It wants the height of the train. This is only, the x here is the distance from his eye level to the train. So you have to add that 5.5 feet back on. So the train height is 5.5 plus 14, or 19.5 feet. The other thing you use the geometric mean for is to find pieces of a triangle that you don't know. So what actually happens is, since these are similar triangles, you're setting up a proportion. So what here is, so XZ is the hypotenuse of the large triangle, XY is the leg of the large triangle. And then if you look here, XY is the hypotenuse of this left triangle, and XW is the leg. So hypotenuse over leg equals hypotenuse over leg. It's just you're switching which triangle you're talking about. And the same thing is true also over here. Hypotenuse over leg is equal to hypotenuse over leg. Which brings us to our last example. Find x and y. So here you have this triangle. So for the big one, the hypotenuse is 6 and the leg is x. So hypotenuse over leg equals, now since I'm looking for x, I'm going to use this triangle here, SRQ. Its hypotenuse is x and its leg is 4. Now I'm going to do cross products. X squared is equal to 24. Take the square root. X is 4.9. The same thing to find y, except you're going to use the bottom triangle. So the hypotenuse of the big is still x. The leg is now y. Hypotenuse over leg Now for the small triangle, PSQ, the hypotenuse is y and the leg is 2. So y squared is equal to 12. Take the square root of 12, and you get 3.5. So, solving for x and y. That's the end of the section.